In this lab, you're going to use this simple device. It's basically a parallel plate capacitor to measure the relative humidity. What we're trying to measure here is percent relative humidity, which is going to be a single value. And the circuit that we're going to use is from our foundation of the basic voltage divider circuit, where we've replaced one of the sensors. And in this case, we're going to use an AC signal instead of a DC signal. So what does that look like? So we've got a couple of choices. This is just one incarnation. And this might look familiar to you to have a resistor and a capacitor in series. So, of course, we're going to replace the capacitor with this capacitive sensor. So let's think about these two different configurations. And by the way, the input is going to be a square wave. And we're either going to choose the one on the left, which is a CR circuit, or the one on the right, which is an RC circuit. Now, it turns out the one on the left is going to be the one that we'll use, and this will become clear in a bit. But the one on the left, you might recall, is essentially a high-pass filter, the same configuration that you saw in the last P-set. So what do we expect out of this? Well, we're going to get a signal that is a little bit like like a sawtooth, so that when the signal changes, it passes through, but then the capacitor bleeds off the signal. And we're going to use the root mean square voltage measurement of that sawtooth signal in order or as an indicator of the voltage. So one half wave looks something like this. And the trick in the design here is to choose an R so that we get that full half wave. And you recall that it decays with a tau value equal to RC. And so you're going to be choosing an R to so that this square wave contains the entire decay of the capacitor. So we want this tau value to be about 1/5 the size of this half square wave. So the tau that we want to design for is going to be 1/5. This should actually say 1/2 T. Because we know that this is just half of the period of the whole square wave. Okay, let us put it all together. We're going to take a RMS voltage measurement that is from that sawtooth wave, and the instrumentation is basically giving us that RMS value with respect to capacitance. So as the time constant changes with capacitance, we'll get a different value. The sensor comes with a transfer function that relates relative humidity to capacitance, and we're going to go from the voltage measured to this relative humidity, and I'm just drawing some curves here just to kind of show you an example. So we want to measure a sense of voltage and then let that get us to the relative humidity value. Okay, what we need to do is develop a curve for the instrumentation. We will take our circuit, and again, the R is going to be the design element here, and the C is going to be our sensor. And this varies from about 100 picofarads to about 300 picofarads, and you'll see that on the specification sheet. So given that, you'll be able to know the range of the time constant. Again, you're choosing the R value. So we want a graph that gives us the V out in RMS versus capacitance. And what we'll do is we'll choose capacitors in the range that we expect to take these measurements, and we'll develop basically a curve so we can relate the capacitance to V out.